wondered how a little fizzing ball turned bath time into luxury? So today, we'll diving into bubbly history of the bath bomb and tell you more about it. A toiletry item used in the bath is called a bath bomb or bath fizzy. Mark Constantine, a co-founder of Lush Cosmetics, created and received a patent for it in 1989. It is a compressed blend of dry and wet components that have been shaped into a variety of shapes and then allowed to dry. The surface of the bath bomb submerged in bathwater effervescence causing elements like essential oil, moisturizer, aroma, or coloring to disperse. Simply put, bath bombs are a common bath product that when mixed with water produce a fizzing reaction. This interaction between citric acid and sodium bicarbonate, as known as baking soda, is a typical illustration of an acid-base of reaction.
What is function of backbone? First, skincare. Backbone can cleanse and soften skin, soften dry skin, and remove toxin. Second, aromatherapy. Backbone can contain essential oil that can promote relaxation, relieve respiratory issue, or invigorate your mood. For example, lavender can help you sleep, while citrus scents can energize you. Next, detoxification. Backbone can help cleanse and repair the body. Color, backbone can add fun color to your bath water. Bubble, bath bomb can make your bath water bubble and fizzy. The fizzing is caused by a reaction between citric acid and sodium bicarbonate in the bath bomb. Next, deodorize. Bath bomb can be used as a deodorize. Second last, foot bath. Bath bomb can be used to create a foot bath. And lastly, skin exfoliation. Bath bomb can be used to exfoliate your skin.
Next, what is exactly in bath bomb? First, NaHCO3 or baking soda reacts with citric acid in water to release carbon dioxide bubbles, creating the signature fizz. Second, C6H8O7 or citric acid combines with sodium bicarbonate to produce the fizz when in contact with water. Third, Na3C6H5O7 or sodium citrate. As a form of chelating agent, sodium citrate aids in the binding of metal ions in water. By lowering the concentration of calcium and magnesium ions, this softens hard water, making the skin feel smoother. Softened water improves the effectiveness of other chemicals like moisturizers or surfactants.
Equation of bath bomb. C6H8O7, which is citric acid plus NaHCO3, baking soda became Na3C6H5O7, sodium citrate plus H2O plus CO2, which is carbon dioxide gas.
Next, we go through the pH of bath bomb. The balance of acid and base determines the product's pH, which is typically kept skin-friendly or close to neutral. Sodium bicarbonate, which is NaHCO, known as weak base, dissolved in water, which is H2O. The pH value is starting from 8 to 9. For citric acid, C6H8O7, as known as weak acid, the pH value is 3.24. For sodium bicarbonate, C6H8O7 plus citric acid NaHCO, the pH value is 7. For the sodium bicarbonate, C6H8O7 plus nitric acid plus citric acid NaHCO plus water H2O, the pH value 5.5 to 6.5, which is skin natural pH, help maintain skin health. Next, we go to the emulsification. Why adding oil in bath bomb? It's for skin conditioning properties and fragrance. How can the oil not forming a separate layer? Emulsifiers are used such as cocamidopropyl betaine, which is emulsifying also forming properties, and polysorbates, it helps disperse oil evenly in water and prevents residue. For this process, oils and emulsifiers are released, allowing the oils to mix with the water without layers.
How the scent of bath bomb spread. The fusing action between sodium bicarbonate and citric acid with water produce carbon dioxide gas help distribute both fragrance. Emulsifiers like polysorbates breaks oil into tiny droplets that spread evenly, enhance fragrance diffusion. Most fragrance oils are hydrophobic, so emulsifiers help to integrate with water to extend. Solubility of certain scents of molecule in water allow them to diffuse through the bath water and to the surrounding air.
Effect of temperature on reaction. The first one is higher temperature. Speeds up the reaction. Increased thermal energy causes the molecule of citric acid and baking soda to collide more frequently and with greater energy, overcoming the activation energy barrier faster. As a result, CO2 gas is released more rapidly, creating more vigorous fizzing. The second one is lower temperature. Slows the reaction. The molecules move more slowly, reducing the frequency and energy of collision, leading to a slower release of CO2 gas. And lastly, effect of temperature on gas solubility. CO2 gas is less soluble in warm water than in cool water. As the bath water temperature rises, CO2 escapes more easily into the air, enhancing the freezing effect and the sensory experience.
What makes bath bomb dissolve faster? First, smaller size. A smaller bath bomb will dissolve faster because it has a greater surface area relative to its volume. More surface area allows the water to react with the ingredient more quickly. Second, water temperature. Hot water. Hot water increases the dissolution. Heat causes molecules to move faster, which increases the rate of the chemical reaction between the citric acid and sodium bicarbonate, as well as the speed of the bath bomb's dissolution in water. Typically, warm to hot water speeds up the fizzing and dissolving process. Next, cold water. In contrast, cold water will slow down the dissolution process as the lower temperature reduces the reaction rate and the solubility of the ingredient.
Next up, presence of water. Water trigger for the reaction without water will not occur. Reaction rate increase with more water because it dissolves the reactants. Fourth, surface area of ingredient. Fine powder of sodium bicarbonate and citric acid react faster because it have larger surface area allow more collision between reactant molecules. After that, the temperature. High temperature increase kinetic energy of molecules, leading to more frequent and energetic collision. And then concentration of reactant. Higher concentration of baking soda or citric acid leads to fast reaction because more molecules are available to collide and react. Last one is shape. A bath bomb with irregular edges or a more rough surface compared to a smooth one will dissolve faster because the water can interact with more surface area, speeding up the dissolution process.